Okay, let's have a word of prayer. Mighty, omniscient, loving God in heaven, I want to thank you for the gift of life you have offered us, God. I want to thank you for this opportunity you've granted us this morning, mighty Father. As we are going to study, give us more wisdom and understanding. We pray that whatever thing is going to be taught by our teachers be crossed into our mind, mighty Father. Bless our teacher as he's going to teach. Give him more wisdom, understanding, mighty Father, to teach us. And we pray that whatever thing we are going to be told may be grasped, mighty Father. Come and be with us, afraid of believing and trusting in thy name. Amen.
And thank you so much for the word of prayer. You're most welcome, everyone. Today we are going to continue with our concept on the equation of a plane. So last week we ended when we were looking at the equation of a plane, and we say that whenever we have a plane, there are some things that are very important for us to take note of. We say that we must have a normal to the plane, and we must have a vector onto the plane. And we say that once a perpendicular, this normal meets with any vector on the plane, then the dot product will equal to 0. So we say that n dot ar will always equal to 0 because they are perpendicular. So we looked at this case whereby we had one vector, or we had a vector and we had a norm. So we are going to look at now other cases that we can encounter. So we went on and also we summarized this as n. When you have n and you have r, should you give us n dot what? Dot a. So we looked at this and we said that this is the general equation of a plane. But we say that our equation of a plane can be written either in a scalar format. It can as well be written in a vector format. So we looked at all those things. And also we say that it can be written in the Cartesian format in the form of ax plus by plus cz then is equal to d. So we are going now to build up from here and look at other cases we can encounter when it comes to the equation of a plane. The first one, we are going to look at this case whereby they're asking us to write down the equation of a plane containing the point -837 and is parallel to the plane given by this. What do you need to know? Now, I know you are going to read books or you are going to find text. Whenever you find something like this, this one stands for plane. When you find such, this one stands for the plane. And when you find a 1 here, it means that is plane 1. When you find something like this, then this means this is the second plane. So they're telling us that they want us to find the equation of the plane containing this point and is parallel to a plane given by this. So when you look at my diagram here, I'm showing that this is our first plane and this is our second plane. But they have given us the equation of one of the planes. Let me say they have given us the equation of the second plane, which is 4x plus 8y minus 2z is equal to 45. But they have told us that these two planes are parallel. Now, if these two planes are parallel, what do you need to know? That one is that the normal vector that goes through the first plane is the same normal vector that goes through the first plane. So that means that the normal vector, this vector you're seeing here, the norm, is the same for both planes. That means that if you know the normal for this plane, you'll also be able to know the normal for this plane. But the beauty is that we have one point along that plane, and that point is given by -8, 3, and 7. So what did we say? We say that in order for us to be able to get that point, or to be able to get the vector, it's just a matter of us saying r dot n, whereby n is our normal, is equal to our a dot n, whereby a is any point on the plane and n is the normal to the plane. But what did we say? We say that whenever we have a plane, in order for us to be able to get our norm, always our plane is written in this format: ax plus by plus cz is equal to d. what you have as your A, what you have as your B, what you have as your C are what forms the plane's normal. So that means that our normal is always given by A, by B, and by C. So mere looking at this plane that we have been given, it means that our normal is going to be, we extract the coefficients, it's going to be 4, 8, and then negative 2. So that is our normal. And this normal here is going to be the same normal for the second plane, since those planes are parallel. So any vector that is perpendicular, that is normal to the first plane, will be the same vector that is normal to the second plane. So what are we going to do? We shall come here and say that now our unknown point is going to be x, y, and z. We dot it with the normal, which is 4, 8, negative 2, is equal to our A, which is the known point, which is negative 8, 3, 7, and then we are going to dot it with our normal, which is 4, 8, and then negative 2. So when we multiply, we shall have 4x plus 8y minus 2z is equal to, so we multiply this side as well. Negative 8 times 4 will give us a negative 32 plus our 3 times 8, which gives us a 24, then plus the 7 times negative 2, which will give us a negative 14. And once you do the mathematics, plus 24 minus the 14, you end up with negative 22. So that means that our plane is going to be 4x plus 8y minus 2z is equal to negative 22. So members, is that fine? Are we together up to that point? Okay. Okay, members are very okay with that point. Are we going to continue? Now, if we want to visualize this on the Cartesian plane, allow me to, I'm going to end this show, but I think I'm going also to clean the screen, thinking that members have finished. Okay, so allow me to clean the screen. So if I'm to have this on a Cartesian plane, how does it look like the visual? Now the visual, I'm going to come here and I put the first plane we had. So the first plane that we had was 4x plus 8y uh, minus 2z equals to 45. Then the second plane we had was 4x plus 8y. Okay, here I'm going to remove this. It is 4x plus 8y minus 2z equals to negative 22. So that's what we have got. So allow me to change the color of this such that people can be able to see it well. I think I can use this color. Okay. Okay. And also this one, I can change the color and such that it is a bit clear. Okay, so when you look at my screen, that's how those two planes look like. I think now you hope members are able to see my screen. Members, are you seeing my screen? Is my screen showing the two planes? So that's how those two planes look like when it comes to real life or when you draw them. So they look like that. So they will be parallel to each other. So that is what we have been working on. So which plane have we been? Now this green one, let me remove it. What they gave us this plane here. This is the plane they gave us here. So now what have we been looking out for? We have been looking out for the plane that is parallel to it. Like we have another plane that is parallel to it, but we wanted to find out its equation. So when we find out its equation, we found out that its equation is like is like that. So that is how those two planes look like. Okay, so we are going to continue. Uh, okay, now the next we are going to look at this special case. We have started now our special cases. The first one we are going to look at, how do you find the equation of a plane whereby you have a point and you have a line. You have a point and you have a line. That's what we are going to look out. What does it mean? I'll give you an example that if I have a plane, we said that a plane means a flat surface. So if I have this as my plane, let me say this is my plane, and I have a point onto a plane. Let me say this is a point on a plane, which I can call A. But also I have a line. A line, let me say this is a line. What does it mean? If I want to obtain the equation of this plane, there are two important things you have to do. One, we say that you must be able to know the normal of that plane, the normal to the plane. Number two, you must know at least a point on the plane. Now, what is the beauty is that when we have a line, we know that a line has a vector. A line, any line we have always will have what? A vector, because you know that a line is given by r is equal to a plus lambda times d. Now, a line has this direction vector. So for this particular line here, its direction vector, its vector we can use is the d. But when you have one vector, you cannot be able to get a normal. So here, they are hiding the normal from us. What does it? It means that we must be able, we must, it means that we must be able to find out the normal to this particular plane. So what do we do? Now, since we have this point here as our line, and we know that this point A here, let me call this B now, instead, since we have A. A is a point on this line. This is A. This is the point. What do we do? In order for us to be able to find the equation of the normal, I'm going to first find out, I'm going to look out for this point A and this point that has been given to us, something like this. I join such that I have two vectors. I have this as my first vector. I also have this as my second vector. And we say that whenever you have 2 points, let me say, this is your vector. Let me say this is your vector 1 and this is your second vector v2. In order for us to find the normal, members, tell me in the chat, what do we do? If I want to find the normal to these two vectors, what do we do? Let me see whether people remember. I have two vectors and I want to find a normal to those vectors. What are we going to do? What concept do we use such that we find out? Thank you, Jimmy. Jimmy has said we get the cross product. Therefore, in order for us to get the normal vector, we shall have to get the cross product of the first vector times the second what? Vector. So that's what we are going to be able to find out. So whenever you are given an equation of a line and you have a point, the first thing you have to get is the normal to the plane. And the normal can be obtained by getting the cross product of the vector that you do have. So we are going to look at the first example. When you look at my screen, they have given us a point. I can first make a small sketch. So when this is my sketch, they have given us our line. This is the line they have given us. What am I going to do? I can draw my line here. And when you look at this line here, you know that it has a direction vector. And allow me to call that direction vector V1, which is going to be 2, 7, and -3. What is always down is what forms our direction vector. But that direction vector has a point. And this point here, it has here is a point which is given by 3, -1, and 2. But they have also given us a point along. So that point here is here. Here I'm going to call it A, and this point B, it is the point that has been given 2, -1, and 1. So members, let me know through the chat whether we are still on the same point with my sketch. Is the sketch fine? Is the sketch okay? Aha, very good, very good. Now, what am I going to do? I'm going to get the second vector, and my second vector is going to be this vector, which is A to B. So I'm going to first find out AB, and we know that A to B is given by our O to B minus O to A. So what is our O to B is 2, -1, 1, minus our O to A, which is 3, -1, and 2. What are we looking out for? AB. So I'll come here and I say now, my A to B is going to be 2 minus 3, which will give us a -1, -1 minus -1, which gives us a 0, and 1 minus 2, which gives us a -1. So now this is going to be our second vector, and that's what I'm calling V2. So that means that in order for us to get the normal is going to be given by vector 1 cross vector 2. So here we shall have now our normal as I, J, and then the K. Our first vector we shall use is 2, 7, and -3. And our second vector is going to be -1, 0, and -1. Now, may I ask everyone to first find for us the normal vector, and you post your answer in the chat. Okay, I'm looking through the chat, the answer people are coming up with. Mhm. Oh, we are, okay, okay. We are finding the normal. We are finding the normal. We are finding the normal. So I expect you to, okay. So I expect people to find for me the cross product such that we get the normal. So that's what people are calculating. Okay, so let me hope people are trying out. The only problem, I'm seeing the answers are a bit different in the chat. Remember, we say that what we do, we remove the I. So when you remove this and this, we remain with this. So when you check out very well, I'm not seeing. that here I'll remain with 7 times negative 1, which is negative 7i. Then this one is 0. When I go on to the second, you note that for the second, I'm going to have this go away and this go away. So I'll have 2 times negative 1, 2 times negative 1, then have negative minus the negative 1 times negative 3, which gives us negative 2 minus 3, which gives us a negative 5. And hope that is okay. So when it gives us a negative 5, remember there is also a negative here. So since there is a like here for I, we put a negative, it becomes a positive 5. Okay, yes, positive 5, good. So here we shall have plus 5j. And then for the last one, it is going to be, and this is 0, this is negative, negative, which will be a plus 7, a plus 7k. So that's what we have. Those answers I'm seeing in the chat are very okay. Now since we have the normal, then members, now we can go on and find out that particular point. Remember now we said that our normal vector, if it, sorry, okay, okay, it is okay. You can write the normal vector times r, or you can say r dot n will equal to our point A dot n. Now, when you are choosing a point, here it is okay. As long as that point is on the plane, that point will work. So what is going to be our r? Our r is the x, y, and z dot our n, which is the normal vector, which is negative 7, 5, and 7, is equal to your point A. Now, point A can be any point as long as that point is on the plane. It can be this point, it can be this point. So for whatever point you use, you get the same answer. So I'm going to use 2, negative 1, and 1. Then I dot it with our plane, which is negative 7, 5, and 7. Yes, Dr. Peace. Dr. Peace?
Good morning, sir.
Yes, morning.
I was just, I'm confused, in fact, from this N, the N you've got. That value of K for me, I'm having 9.
Which one? How did you get 9?
Like when I'm getting the K, I crossed like 2. Oh, sorry. I made that
Okay.
mistake. Instead of
Okay.
I wrote 2.
Oh, okay. First complete for us this now. So when we dot this side, what shall we have?
We shall have negative 7x plus 5y
Plus 5y
plus 7z.
plus 7z equals to,
There we shall have negative 14 plus minus 5, then plus 7.
okay. And what shall we end up with?
Let me compute and see. It will be negative 12.
Negative 12 or sure, negative 12, eh?
Yes.
Okay. Thank you. So here we shall have our negative 12. Thank you. So this is going to be now our equation for the plane. Members, are we on the same page? In case you have a question, feel free to ask. Even someone who used point A, members here, it is also okay. It is also okay. In case for you come here and use A, you get the same answer. So someone who said x, y, z, negative 5, 7, 5 is equal to, as long as you have maintained your normal, even if you use 3, negative 1, and 2, multiply by negative 7, 5, and 7, you get the same answer. Okay, someone has confirmed. Someone has confirmed that they are getting the same answer. Yes, Ms. Mentor. Why are we equating? We are not equating. It's just we are filling in the equation. we are filling in the equation. Remember, the equation of the normal is given by this. So you need to just know r dot n is equal to a dot n, and these are vectors. Okay, yes, Jennifer? Ms. Meta? Okay, I'll fail to get Ms. Meta. Kauthra?
Excuse me, sir.
Yes, morning.
Good morning, sir.
Yes, morning.
Good morning, sir.
Yes, morning, morning.
Excuse me, sir. Pardon. Well, I'd like to pardon me on how you got the cross product. I think I missed that lesson.
We said that for cross product, you do I, then you get the magnitude. So when I cross out I remain with 7, negative 3, 0, negative 1. Then minus j, cross out the j. The moment you cross out the j, you remain with the 2, negative 1, negative 3, negative 1, plus the k. Then cross out the k, then you remain with the 2, negative 1, 7, and 0. Then you get its determinant by multiplying elements within the major diagonal minus the elements within the minor diagonal. Hope you have got a hint. Okay, so that's how you do the cross product. Okay, I have another one here. I don't know, Kauthar, have you got a hint?
Yes, sir.
So you just keep eliminating. So for you, the moment you have I, J, and K, you have anything. Maybe it is this. What you do, cross out the I. And once you cross out the I, it means you remain with the 2, 1, 3, 5. For the J component is negative, then cross it out, get 1, 4, 3, 5. Plus the K, cross out the K, then get 1, 4, 2, and 1. And then do the mathematics of getting the 2 times 5 minus 1 times 3, everything is of I. Minus J, multiply the elements minus, like that. Okay, so members, I have another one here. So I'm expecting you to be going through it. Go through it. So we have that engineering team. They have given us the reference board. They have given us the point, and they want us to find, they want us to work it out to find, using vectors, what we call the Cartesian equation of this particular plane. So I do expect you, when you look at this is what we call the parametric format of our equations. So when you find x into t, it means that our x has been written in terms of t. That is the meaning. So I'm going to ask you, the first thing always you do, feel free to come up with your simple sketch. And say now, when you look at this, when it is given this, don't forget that this is a line. Have your line drawn. The next thing, identify what is the point on the line. 2, identify what could be the direction vector of that particular line. Remember, direction vector is also a vector. And then what point has been given to us. Members, are we trying it? Yeah. How do we get point A as 3, negative 1, 2? Yes, Musmenta, we said, remember, when they give you an equation, let me say they have given us this. I'm just using this as an example. X minus 3, y plus 1 out of 1 is equal to maybe z minus 2 out of this. We say that what you have here, and here are your coordinates. These are our coordinates. So this one is always equal to this lambda. If it is confusing you, what you do, always say when lambda is equal to 0, so you'll have x minus 3 out of 2 is equal to 0. So your x minus 3 will equal to 0 and x is equal to 3. Then you could do the same. Y plus 1 out of 1 is equal to 0. So y plus 1 will equal to 0. Y is equal to negative 1. Then also z, you say z minus 2 out of 3 is equal to 0. So z minus 2 will equal to 0. Z is equal to 2. Yeah. So in case you want to find the coordinates, always equate your lambda to 0. The moment you equate to 0, you can be able to get the x, y, and then the z component. Hope, Musmenta, that is very fine to you. So that's how we came up with that 3, 1, and negative 2. How do we get the vector equation? Yes. How do we get the vector equation? Yes, the vector equation. Can someone help us? Who is going to share with us how we get the vector equation? If this format is confusing you, the parametric, Dorcas first convert it into a Cartesian format. If you feel it is confusing you, convert it into the Cartesian. But do not forget Dorcas. Dorcas will say that when we write this, this is x, y, and z. So you can first write it even in this format. Negative 6 plus 8t, 1 plus 6t, and then 5 minus 2t. And you know very well that this is the same as negative 6, 1, 5. Now here you'll have your plus. Here the parameter is t into 8, 6, and negative 2. And this is your line. So we say that this point here is the known point on the line. And what we have this side is the directional vector. Hope, Dorcas, that is okay. AB, Matthias is getting 11, 7, 6. So members, let me hope now everyone has been able to identify what your A is and what our B is. Good. Yeah, you can draw a sketch. And what I want to, you can draw a sketch, no problem. Draw your simple sketch, have your vector, which is the direction vector. And for this case, it's going to be 8, 6, and negative 2. Our point along this line here has been given to us as negative 6, 1, and 5. So you can call this point A, and you have a point which is B, which in the question they have given us 5, 8, and negative 1. So make sure that you find AB. From AB, go on and get the cross product. And from the cross product, let's go on and find the normal. Okay. But in case you get stuck, raise up your hand and then we can support you. In case you feel there is somewhere where you're getting stuck, raise up your hand and then we support you. Okay. Yes, Ronald King. Ronald King, unmute, yes.
Yes. Yes.
Yes, please.
Good morning, man.
Morning.
Master, I'm just requesting that you repeat what you told Dorcas. The concept that you told Dorcas there, I didn't understand it because this format is also confusing me.
Okay, I'm going to repeat. I'm going to repeat this thing. We said that the format we have here is what we call the parametric form. So if I have x is equal to negative 6 plus 8t, I may decide to write this by taking the negative 6. So when you take negative 6 this side, what shall we have, Ronald? Yes? So that will be 6
X
plus
plus
6
6.
is equal to 8t.
X.
So that means that you can have
Mm.
x plus 6 out of 8 is equal to t. Is that fine?
Yeah.
When you look at the y is equal to 1 plus 6t. So you can do the same. Y minus 1 is equal to 6t. And then you say y minus 1
Mm.
out of 6 is equal to
All
t.
right.
Then you go to z.
Yes.
Z would be z minus 5 is equal to negative 2t. And therefore your z
Mm.
minus 5 out of negative 2 is equal to t. And therefore you can write your equation in the form of x plus 6 out of 8 is equal to y minus 1 out of 6 is equal to 7 minus 5 out of negative 2. Then if this is
Thank
the
you, sir.
format that, then you extract the direction, extract the points.
Okay.
Okay.
I'm good to go. Thank you, sir.
Okay. Okay. And so I'm sure people are working. But someone can raise up the hand and you take us through your AB, what you have obtained as your second vector. We are calling AB. Okay. Yes, Gilbert.
Good morning, sir.
Yes, morning.
AB is set by
AB.
AB equals OB minus OA.
Okay.
So our OB is 5, 8, negative 1 minus negative 6, 1, 5.
Okay.
So 5 plus 6, that is 11. 8 minus 1, that is 7. And negative 1 minus 5, that is negative 6. Then think that's our AB.
Okay, good. Thank you. Another person to take us through how we obtain our normal. Okay. Yes, John.
Thank you so much, teacher. Good morning.
Yes, morning.
So to get the normal, we are going to get the cross product of the two vectors, which is V1 cross V2.
Okay.
Writing it in that format of the I, negative J, and K.
Okay.
And filling in the two vectors. So 8, 6, and negative 2. And below we shall have 11, 7, and negative 6.
Okay.
So for the first vector component of I, we shall have 6, negative 2, and below we shall have 7, negative 6.
Okay.
The I on the side, then minus, above we shall have 8, negative 2, and below 11, negative 6. Plus, above for the K component, 8, 6, and below we shall have 11, 7.
Okay.
Yes, so after that, we are going to find, for the I, we shall have 6 times negative 6, giving us negative 36. And if you realize, when you multiply 7 times negative 2, it's negative 14, so that will be plus 14. And then we shall have minus, open brackets, 8 times negative 6, that will be negative 48. The same case, 11 times negative 2 is negative 22, so that will be plus 22. j. Then plus, again, open brackets, 8 times 7 giving us 56, minus 11 times 6, which is 66k.
Okay.
After the completion for I, it will be negative 22i. You realize for j in the brackets, it will give us negative 26, but there's also a negative sign outside, so it becomes plus 26. And then for k, it will be negative 10, giving us the normal.
Okay. Thank you. Thank you so much, John. Can we have another one to take us through now our final, the equation of a plane? Okay. Yes, Linda.
Good morning, sir.
Morning, Linda.
Yes, from our formula,
Mm-hmm.
R equals, R dot n equals to A dot n.
Mm-hmm.
R is in the form of x, y, z dot the normal, which is negative 22, 26, negative 10 equals, our normal is negative 22, 26, then negative 10 dot, we pick any point, let us take negative 6, 1, 5. So we shall have negative 22x plus 26y minus 10z equals to, we have negative 26 times, negative 6 times 20 times negative 22. There we are getting 132 plus 26 plus negative 20, negative 50 minus 50. We are getting 108.
Okay. Can this be reduced further? Is there anything that can be reduced?
Yeah,
Okay.
we can go by 2.
Okay, by 2.
11, negative 11x
Mm-hmm.
plus 13y
Mm-hmm.
minus 5z
Mm-hmm.
equals to 54.
Okay, okay. Thank you so much, Linda. Yes, so members, that's how you conclude, and never leave it when you have not reduced to its simplest form. So always make sure that you simplify to its simplest form. Yes. Yes, yes. Yes, Akram.
Good morning, sir.
Morning.
Sir, for me, I have a question. What if you use
Mm.
BA as your direction vector? Is the answer the same?
When you use BA.
BA. Yeah.
Uh-huh. Now remember, the answer will be the same. Remember, we said that when it comes to cross product, vectors can be going away or vectors can be coming at the same point.
Okay,
Is
sir.
that okay?
Yes. Thank you.
You'll get the same answer. Yes, Dr. Peace?
Teacher, actually, it's not part of that question, but I'm just asking if they ask for parametric equation format, can you use this, or you can only use the other second method we used last time?
If they ask for?
Parametric equation.
This
Of
is the parametric equation.
I mean that when it's not given and they're asking for it, like, can you use both the methods, or you can use only the second method? Because according to the previous exercise you left, I was stuck because I couldn't use the first method to get it.
Oh, okay. I'm not getting you well, what you are meaning, but this is the parametric one.
Yes, so teacher, I'm asking if it's not given and the question is asking for you to find, like, for you to get the parametric equation of the plane, like maybe the maybe ABSC, like the other first examples we had, and they tell you to find the parametric equation for the plane. So I'm asking whether we can only use the other second method of solving simultaneous equations, or we can even use the, like, get the parametric equation using this method of r dot n equals a dot n.
Oh, okay. Now this one cannot lead you there. This one cannot lead you there. So you have to use that because that one.
Oh, okay. I
And
was stuck yesterday because I was trying to do those numbers, but I said maybe this one you just use the second method alone.
oh, yeah, because now that's what we call the vector equation of a plane. So it is the vector equations that can lead you to the parametric equations.
Okay, sir. Thank you.
Okay. Okay, so members, we are going to go to the second bit of it. Okay, and let me hope we are on the same page. Okay, now we are going to look at the second case. The second case is whereby we have 2 points on our plane. Take an example. You have this as your plane. This is our plane. And on this plane, you have a point. Let me say this is point A and this is point B. Now, when you have 2 points along the plane, these points are going to be at a reference point with the origin. So here we shall make an assumption, or we shall always assume that their reference point is the origin. In other words, you'll have your O to A and then you'll have your O to B. And what do you need? The only thing you need now is to find the normal to these 2 vectors. And therefore, for that case, our normal to the 2 vectors, this normal here, can be obtained still by crossing OA and O to B. So this O here, the origin, is 0, 0, and 0. That is the origin. So whenever you have 2 points, then it means that the other third point you are using is the origin, which is O, O, and O. So this is the case. But still the first thing you find out is you find out the normal to the vector, the normal to that particular plane you are working on. So we are going to look at this. They have told us that with respect a fixed origin. So that means that when I'm drawing my plane, this is the plane, and at this plane we have our fixed origin, which is O to O. You have your point A and you have your point B. Point O to A is a vector, which is A. And now our O to B is a vector, which is B. What does it mean? We say that cross product is the one that will help us to find a normal, as long as we have 2 vectors on that plane. So the first vector is A and the second vector is B. So in order for us to find a normal, which is very important, we shall say that our normal will equal to the cross product of A cross B, because this is the only way we can be able to find our normal vector. So, or someone can just say that my normal will be my O to A cross O to or to B. That one is also very, very fine. So when we come back, you can notice that we have our I, and now people prefer putting negative J and K. So our A is this point here, which I'm going to put as 3, -1, and 2. Our point B is 2, 1, and -1. So what do we need? We need to get the normal. So we do the same way we have been doing to get our normal. So we can have someone give us that normal. Give us the normal. Anyone who wants to take us through from that point and you get for us the normal? Okay. Baswali?
Good morning, teacher.
Yes, good morning.
Good morning, teacher. Okay, now we have 3. If you take away the I component, we shall remain with the -1, 1 down, and -1 in the I.
Okay.
Then that we shall remain with 3, 2, 2, -1. And in the K we shall be having 3, -1, 2, 1.
Okay.
And then we shall have, because -1 times -1, it is 1. Then -1 is -1.
Okay. You're giving us the final one. Okay. It is okay. -1.
Then in the J, we have 3 times -1, which is -3, -4, which is -7.
Continue.
Teacher, isn't that negative? The 7.
There is a negative here.
Oh, yes. Thank you, sir. Then in the K, we shall have 3 minus, which is 5 in the K.
Which is 5.
5.
Okay.
Yeah.
Thank you. Thank you. Okay.
Okay,
So this is our normal. So the next thing we do is we go on and find out what our equation is. So we shall say that our R dot N is equal to our A dot N. Yeah, so that one can work. So this will give us our X, Y, and Z into our normal -1, 7, and 5 is equal to A. Here, feel free, you can take A, you can take B. Any point you choose, you will get the same answer. So I'll have 3, -1, and 2 dot our N, which is -1, 7, and 5. Yes, Tashobia? Tashobia, unmute.
Good morning, sir.
Morning.
Now there is something that has confused me. There, when you are starting the equation for the normal, remember you put I, and where you put the magnitudes, you put I, -J, and K. Now I'm asking myself, where did you get that -J?
Oh, now that one came from the principles. Like when we are at Australia starting this topic, we say that when I have I, J, and K, whenever I'm moving in the anti-clockwise direction, I cross J, when you cross I cross J, you end up with a K. When I cross J cross K, I end up with I. But the moment I reverse the direction like this, and I have let me say I have J cross I, then those ones gives me a negative. So the negative is because we are changing the direction. that when I remove this j, I'm crossing I cross k. So you notice that I cross k is a change in the direction. So that's why we get negative j. Is that fine?
I get. Yeah, it's
Yeah.
fine.
Okay, yeah. So that's where it originates from. Okay, so members here, we shall end up with negative x plus 7y plus 5z is equal to, am I getting a 0 like Q? Oh, aha, good. So here we shall end up with a 0. Very good. Okay. How is this different from the previous one? The previous one, they had given you a line and a point. Here, they have given you 2 points on a plane. So that is the difference. For the first one, there was a line that was going through the plane, and you had 1 point on the plane. Okay. Are we good to continue? Uh, okay, people are saying we can continue. Okay. Can you do for me this quickly? This is yours for trying out. Yeah. This is yours for trying out. When you finish, you are going to place your answer in the chat. Yeah, so try and then we see. Don't forget we go through all the different procedures. And here, do not forget that your normal is very, very important. The moment you mess up with a normal, it means you have messed up with everything. The moment you mess up with a normal, you have messed up with everything. It is that normal that matters a lot. Okay, that is something I've noticed. There's something I've noticed. That I know people have already started. Yeah, there was a reason for putting this number, but it is okay. It's okay. Yeah, I've noticed it. Yeah, but I think what I wanted here, I wanted to just show you how it can be set in the scenario format. That's what I wanted here, how it can be brought when it is a scenario point. but it's okay. It's okay, people, to try it individually. Mm. Okay. Okay. I think, members, we can continue, right? Are we good to continue? Yeah, well, even if you use B, yeah, even if you use B, it is the same. In the formula, whatever point, as long as that point is on the plane, yeah, as long as that point is on the plane, you get the same thing. Yeah, for you, the moment you check and you notice that it is on the plane, then it is okay. You get the same answer. And how do we check that the point is on the plane? Because I may not get time. How do you check that the point is on the plane? What you do, in case now I have a coordinate 3, -1, and 2 as a point, and they have given me plane. The moment I substitute this, I must be able to get 0. Or I get, in case there is a digit, I must be able to get that digit. So when you come here and substitute -3 minus 7 plus 10, your answer will be a 0. So that confirms that that point is on the plane. So for you, whatever point you choose, as long as it is on the plane, then you'll be able to get your answer as that. Okay. Now, the third situation. The third situation is an equation of a plane containing 2 lines. You have your plane and we have 2 lines. Now, let me say this is our plane. I think I can, I don't know that I can show you. Yes. I think I can show you something before we start on this one. Let me stop sharing here the slideshow. Okay. Oh, wanted. Oh, okay. Sorry about that. Take an example. We are going to look at a situation whereby you have 2 lines on a plane. I'm going to open my PowerPoint again. We are looking at a situation where we have a plane. Sorry, where is it? We have a plane containing 2 lines. What does it mean? If you have 2 lines, this is what it happens. So I'm going to come here and I first put for you the lines and then you check it out. So I have my first line as x minus x minus 2 out of 3 equals, I want you to visualize how it looks like, equals to y out of -1 equals to z minus, equals to z minus 1 out of 2. Okay, that is my first line. Then I want another one. Okay, this one I'm going to first delete that one. Then I want another one, which is x, sorry, this one is going to be x minus, x out of 3 equals to y minus 4 out of 1 equals to z minus 5. Sorry, let me. Z minus 5 out of -2. That is one of the lines. Okay. I don't know whether you can see this line. Let me see whether I can get it very well. And then, okay, I don't know whether it is visible. Okay, I'm trying to look to get this line here. Okay, that one. I don't know why this one is not showing up. But let me see whether I can still get it well. X minus 2 C3 equals to y out of -1 equals to z minus 1 out of 2. Yeah. Now, that is how those lines are going to look like. So when you look at these lines, you can note that these lines are not meeting. But now that means that when you are dealing with planes, when you are dealing with two lines on a plane, you must first check. And one of the things you are going to check is that what is the nature of those lines? If those lines are not meeting, are you seeing here? It means that the approach you are going to use is different. So you'll have to check the nature of the lines. Are the lines parallel? Are they intersecting? Or are they skew lines? When I try to change here, I'm going to change a point and then you'll see the difference. Let me say I put here 5. And so when you check them here, now you notice that the nature of the line has changed. Now these lines, let me see whether I can change another thing here, and I say whether I can get something. Now you notice now that these lines here are, I don't know whether I will be able to achieve the results I want. I wanted to show you something. Now these ones now still do change. So we are going to first be checking for the nature of the lines, whether the lines are intersecting, whether the lines are parallel, or whether the line is skew. So when you find two lines on a plane, when they want you to find the equation of the plane, the nature matters a lot because each of them has its own approach. So that is what we are going to look out for. So we are going to look out for the equation of a plane when we have two lines. But what is the beauty? The beauty is that when you have a plane, there are 3 cases when you have the lines. Like I've showed you one, that your lines may be parallel. Once the lines are parallel, it is a different approach we use. If the lines you have got are skew, like we said, skew lines do not meet at any point. If the lines you have got are skew, here we shall not have any solution. So here we cannot continue with it. Then if the lines you have got are intersecting like that, then there we can find the equation of a plane. The equation of a plane can only be obtained when we have parallel lines and when we have lines that intersect. For skew lines, we do not have or we do not get any kind of a plane. So take note of that. And how are we going to deal with this? Now, the first case we are going to deal with is going to be when these lines are intersecting. That is the first case. How do we deal with that case when the lines are intersecting? Now, in case I have two lines that are intersecting, say I have this line here and I have this line. This is line L1, this is line L2. Now, as long as those lines are intersecting, what is going to happen? Since we say that in order for us to find the normal to that plane, we always need we just need to get two vectors. So this line L1 has a vector, which is the direction vector. This line here has a vector, which is its directional vector. So members, how are we going to get the normal? You tell me in the chat, or you can type in the chat. How do you think we are going to get that normal? Cross. What are we crossing? What are we going to cross? Yes, we are going to cross But from the diagrams I've used, what do you think we are going to cross to get our normal? Yes, remember line L1 has direction vector D1 across the vectors of the two lines. And what vectors are those? We are going to be crossing the directions because these directions are vectors. And we said the moment you have two vectors, very good. The moment you have those two vectors, we can be able to obtain that particular thing. So these are the different steps we shall follow, but this is okay. This is very, very okay. Now I come here. They're asking us that find a Cartesian equation of the plane that contains both of the following lines. That's what we have. So what is the first thing we are going to do? The first thing we are going to obtain is find your normal vector. That is the very important thing. Find the normal vector. And how do we find the normal vector? The normal vector is obtained by crossing the directions. But like I've told you, before you continue, ask yourself, what is the nature of those lines? So we are going to first test the nature of the lines you have. Which kind of lines do you have? So when I'm testing for the nature, what am I going to do? I'm going to first test, are they parallel? I look at the direction. So when you look at the direction of the first line here, it is 2, 1, negative 1. Then when I go to the second 2, I have negative 2, 1, and 2. So I ask myself, members, tell me in the chat, is there anything which when you multiply by one of the vectors, you get exactly the same vector? Is there any digit whereby when we say D1 is equal to KD2, when you multiply, you get exactly the same vector? Is there anything you have been able to observe? Is it there or it does not exist? No. Dorcas has said no, no, no. So that means we shall conclude that D1 is not equal to D2. So that means they are not parallel. Now, the next thing is that you are going to test, are they intersecting or are they skew lines? Now, in order for you to test, it means that we are going to express these lines in form of a parametric format. Remember, we said that in order for us to write in a parametric format, we shall say x, y, z is equal to 1, negative 2, and 3 plus your t, which is 2, 1, negative 1. So that means that your x is equal to 1 plus 2t. Your y is equal to negative 2 plus t. And then your z is equal to 3 minus t. And then from there, we are going to come and say, what about for the second r? If you could allow me that for the second r, still we do the same thing. We say we have x, y, and z is equal to negative 1, 3, 7 plus your n into negative 2, 1, and 2. So that means that here our x will equal to negative 1 minus 2n, y is equal to 3 plus n, and then our z is equal to 7 plus 2n. Now, we are going to solve simultaneously such that we find out what is the value of t and what is the value of n. So we said, what do? We equate the x and the x, equate the y and then the y. So I'm going to say 1 plus 2t is equal to negative 1 minus 2n. So when I work it out, I have 2t plus 2n is equal to negative 1 minus 1, which gives us negative 2. Then when I equate the y's, I'm going to get the y and the y. Then I'll say negative 2 plus t is equal to 3 plus n. So that means we have t minus n is equal to, when the negative 2 goes that side, we get 5. So we shall have t minus n is equal to 5. Then the next thing is you solve these two equations simultaneously such that you find out what is the value of n and what is the value of t. So when we solve simultaneously, what do you have? What do you get for your value of t and n? What do you get for your value of t and n? I don't know whether you are going to agree with what I have. I have t is equal to 2 and n is equal to negative 3. Those are the values that you do get for t and n. Then the next thing you have to do is you have to substitute them and find out when I substitute them here and here, are they consistent points? That is the next thing to prove whether they are intersecting or not. So when I substitute 2, I get 1 plus 2 times 2, which is 5. Hope members are getting that. When I substitute here, I'll have 0. When I substitute here, I get 1. I come this side, I substitute for my n, so I'll have negative. When I substitute for n, I'll have -1 minus 2 times -3, which is 5. When I substitute here, I'll get 0. When I substitute here n -3, that is 7 minus 6, which is 1. So I note that these 2 points, this point and this point, are the same. Therefore, I'm going to conclude that, therefore, since the values of, since when you substitute for t and n, you get a consistent value. Therefore, these 2 lines do intersect. And what is the point of intersection? The point of intersection is 5, 0, and 1. So that is the first step. Members, can you first let me know whether that is okay up to that point? Testing for the nature of the lines you have. You ask because that is the first thing. Otherwise, you may work out when you have not tested and then you end up not getting anything. Yes, Rose?
Okay, teacher, for me, I'm confused from here, where you have t minus n equals 5. Like, where did you get this?
Are you seeing this y?
Yeah.
And you seeing this y here?
Yeah.
So when we equate, we have -2 plus t is equal to 3 plus n.
Okay,
So,
yeah, I've got it.
Okay. So I'm looking through the chart. Yes, you need to test. Yes, Matia, because when the lines are not intersecting, and they are not parallel, it means that those are skew lines. And for skew lines, don't meet in the same plane. So you cannot find the equation of the plane. So it can be something to test your understanding. So here, why we are doing it, we want to test which nature of lines that is. Because if they are intersecting, then we are going to use an approach. If they are not intersecting and they are skew, it means that you cannot find the equation of a plane. Yes, Ruth?
Teacher, my question is how, pardon me on, from after getting the values of t and n, from there,
Okay.
how do I get to know that they're intersecting?
Now, what you do, after getting the value of t, I can just substitute it here in this line here. That my t is 2, and you collect like terms. Now, when you get a point for this line and for this line, when they are the same points, then it means that those lines do intersect.
Yeah, thank you.
You substitute for the value of t and the value of n. If the 2 lines, you get the same answer here and the same answer here, it means they intersect. But if the answers you get here are different, then it means that they are not intersecting.
Okay, thank you, teacher.
All right. Okay, so we are going to continue. Why you should test the nature is the approach differs depending on the nature of the line. When you are dealing with an intersecting line, when you are dealing with a parallel line and a skew line, we don't use the same approach when we are finding the equation of a plane. So now, since these lines intersect, members, allow me to, I'm going to clean my board. Since I've already obtained the point of intersection is 501, allow me to first clean now my board. But I will say that it is 5, 0, and 1. So what are we going to do? Now, since we have known the nature of the lines that are intersecting, it means that this is like our plane. You have this line here, which is R. You have this line here, which is R2. This is like R1. Let me call this one R1 and R2. Now, since we have 2 lines and they're intersecting at this point, What does it mean? It means that the next thing I'm going to do is I'm going to find my normal to these two lines. And we say that if we are finding the normal to these two lines here, what do I need to do? Since this line here has a vector, which I'm going to call D1, and this line here has a vector, which I can call D2, it means that the cross product of these two vectors, and for this case, this is a vector, this is a vector. It means that the cross product of the two vectors will give us the normal. So what am I going to do? I'm going to just get my normal. I'll say my normal now is D1 cross D2. And what is our D1? You extract it. Your D1 is 2, 1, negative 1. And what is our D2? Our D2 is negative 2, 1, and 2. So we are going to cross that. I have I, negative j, and k. So this is 2, 1, negative 1, negative 2, 1, and then the 2. So we get our normal vector. So our normal vector, I'm going to say that when we eliminate I, I'll have 2 minus 1, which will end up giving us a 3. So we shall have a 3I. When I eliminate the j, I'll have this is 4 minus 2, which gives 2 times 2 is a 4. Okay, yes, 4 minus negative 2 times negative 1, which gives us a 2. Hope members, we are together. So, which gives us a 2. So here I'll have 3I, but since there is a minus, hope you know that minus of ours, we shall end up with negative 2j. Hope that is okay. Then I do continue. Now, when I continue, I go to the k, which is going to be my 2 minus 2, which gives us a 4. So here I'll end up with a plus 4k. Members, are we still together up to that point? Are we still together up to that point? Or finding the normal? Okay, people are saying yeah. Okay, yes. Now, after finding the normal, after finding our norm, the next thing we are going to do is we are going to get the equation of a plane. To get the equation of a plane, there are very many things you have to do. One, as long as you get any point along that plane, that point can work. Now, along this plane, along this line, you have this point, which is 1, negative 2, 3. Along this plane, you have a point, negative 1, 3, and 7. So feel free to use either this point or this point. If you still want, you could as well use 501. Use any point. Yes. So you'll be working out as I respond to this. So again, cross again that k. When we cross the k like this, we shall have 2, 1, negative 2, 1. So I'll have 2 times 1 minus negative 2 times 1, which is 2 minus negative 2, which is 4. Okay, let me hope it is okay. So I'm going to come back here. I'm going to come back here and now we get our normal vector. So I've said use any point. So then you say r dot n is equal to a dot n. Use any point. It is up to you what you want. So here we shall have x, y, and z dot our n, which is 3, negative 2, 4, is equal to our a, any point, either this, or the point of intersection. For you, any point you want. So I can use the first one, 1, negative 2, 3, and I dot it with 3, negative 2, and 4. So this gives us 3x minus 2y plus 4z equaling to, this is 3 plus 4 plus, is that 12? I think. Yes, 3 plus 2 plus 12. Hope I've multiplied 1, negative 2, 3. This is 3, 4. 3 times 4 gives us the 12. So your equation of the plane now will be 3x minus 2y plus 4z is equal to 19. Kindly let me know whether we are okay up to that point.
Yes.
It is fine? Okay, let me first speak on some hands. Yes, Melissa?
Good morning, sir.
Yes, good morning.
Master, you said that for point A we can use any point. So I use the point of intersection. I'm getting 17.
You use the point of?
Intersection.
And you are ending up with 17.
Yes.
So you have multiplied well?
5
3
times 15
negative.
minus the 2,
Hmm.
12 plus the 4. Is it?
Okay, let's prove it. Melissa, tell us what you have multiplied. Melissa, our direction
5,
is 5, 0, and 1. Then times the
mm,
direction, which is 3, negative 2, and 4. Multiply.
then 5 times 3,
Mm-hmm.
that is 15.
15.
Oh, when I multiplied the other 0 times negative 2, I got negative 2. I've seen. Thank you.
Okay. Yes, Brian?
Yes, good morning, Master.
Yes, good morning.
Master, now I'm requesting to home me to see this thing you said where you can test whether it is perpendicular or there are skew lines. That thing I didn't get it very well.
No, like we said, Brian, because we had a lesson about that particular thing at one point. We said that when you are testing for the nature of the line, let me say as testing for parallel things, always just look at the directions you have. Look at this direction and this direction. Then in case you notice that in these two directions you have, take an example, in case I have 2, 1, 1, and I have, this is my direction, D1, and I have my second direction, D2, as 4, 2, and 2. When I look at these two lines, at these two directions, I'm going to ask myself, are these two directions parallel? How do I prove that they are parallel? For you, just say, when you get this component here and this component, 2 divided by 4. Is it the same as the second component, which is 1 out of 2? This is like x1 out of x2. Like the x of this out of the x of this. Get the y of this out of the y of this. Get the z of this out of the z of this. Now, the moment you find out that the ratio is the same throughout, is the same here, half a half a half, then it means that these two lines are parallel. Is that fine?
Yes, Master.
Now, if you find out that the lines you are dealing with are not parallel, like for this case, you notice that for when I get this direction, this is going to be 2 out of negative 2 equals to 1 out of 1 equals to negative 1 out of 2. Now you notice here the answer is negative 1. Here is 1. Here is negative a half. Now since they are different, it means that these lines are not parallel because there is no
Yeah.
any scalar which when you multiply you get exactly the other vector. Now if they are not scalars, they are not parallel, then it means that they are either intersecting or they are askew lines. So you go on and test. Are you getting it? Now to test is when you express these two equations in a parametric format. I don't know that
Master,
you're
I'm good
getting.
to
Okay, you're
I'm
good
good
to
to
go. Okay,
yes.
okay, okay. If they are parallel, we are going to look at that case. No, the direction, you cross the way you want, doesn't matter, cuts. How do I test whether they are skew? We said when it comes to the skew, you do the same the way we test for intersecting. But the only difference is that when the lines are skew, the moment you feed it here and here, you get different answers. They are not consistent. So then that's when you conclude that they are skew lines. Okay, here we come again. We have another one here. We have another one here. Yes, it is always very important to test because it helps you to know what actually you're working on. Yes. But though, for this particular one, it is okay. We can test. Yes. So, would you allow me now for this one? I use the graph. Allow me, I'm going to use the graphical approach. I'm going to show you on the graph, but write the lines down and you'll be working out. Personally, I'm going to use the graph to show you how they look like. But I want you to go on, first write the lines down, and then I want you to be testing them. I want you to be testing them. But here, allow me to use to use here just such that I don't go through the testing. But you must test the lines. You must test the lines. You must test the lines. But me, I'm going to just do like this: x minus 1 out of 2 equals to y out of negative 1 equals to z plus 3 out of 1. Then I come to the second line. Okay, this is x minus 4 out of 1. Okay. This is y plus 3 out of 1 equals to okay. Z plus, we are testing the nature of those lines, z plus 3 out of 2. Now, I think you can look at my screen. When you check on my screen, those are the two lines. And you can see that for the two lines we have drawn, okay, I think I can put it like that. You can notice that these two lines, okay, let me change the color of this such that you can see the two lines clearly. So when you look at the two lines, you can notice that this one is the first, this is the blue line. You look at the color here, and this is the red one. And you can notice that the two lines are meeting. You can see that the two lines do meet. So if the lines are meeting, then it means that we can be able to find out the other part. Hope that is okay. Okay. Okay, let me go back now. But now, like I've proved that they're intersecting. So, but for you, you have to prove the way we have proved. You have to first prove whether they are intersecting. But now for such a case, I do expect when you are testing, you can first let this be lambda and this be your mu. Then you say now, what is going to be my parametric form? X minus 1 out of 2 is equal to lambda. And here someone else could as well just say, x minus 1 out of 2 is equal to lambda, and then you say x minus 1 is equal to 2 lambda, x is equal to 1 plus 2 lambda. Then come here on the second one, say, for this case, it will be x minus 4 out of 1 is equal to mu. So x minus 4 is equal to mu, and x is equal to 4 plus mu. Yes, so that's how you can do it. Okay, members, are you testing, or I wait for you to first finish your testing? What do you suggest? I first wait for you to finish the testing, or members are now working out? We can now continue. Okay, I didn't. Okay. Okay, so wait. Pardon. How? Okay, how to test. Okay, how to test. Now let me still continue with the testing. Now, that means that this is for x and this is for x. Now, after equate that 2, so I'll have 1 plus 2 lambda is equal to 4 plus mu. So this will give us, when you put it into simultaneous, to be 2 lambda minus mu is equal to 4 minus 1, which is 3. So this is going to be your first equation. Come to the second one. We have the second one is for y. Now come and say y. You say y out of negative 1 is equal to lambda. So meaning y is equal to negative lambda. Then come to the second one. Still the y component. Y plus 3 out of 1 is equal to mu. Oh, then come here and say this is y plus 3 is equal to mu. When you cross multiply, then you'll have y is equal to mu minus 3. So since these y's are the same, equate them. That means negative lambda is equal to mu minus 3. So simultaneously, it becomes negative lambda minus mu is equal to negative 3, which you can write as lambda plus mu is equal to 3. So I have two equations, 2 lambda minus mu is equal to 3, and lambda plus mu is equal to 3. May I know whether now people who are finding the problem, whether that is very okay? Now, those are the two equations you have to find. After getting these two equations, solve them simultaneously. Find the value of lambda, find the value of mu. So for such a case, I can just go on and I add, because this is negative mu and mu. So I end up with 3 lambda is equal to 6. So my lambda is equal to 2. And now you'll find that your mu is equal to 1. What do you do after? Place them here. Place them in and ask yourself, do I get the same answer? So here, though here it may disturb you in case you don't know how to deal with. So you say x minus 1 out of 2 is equal to lambda, which is 2. So that means x minus 1 is equal to 4, x is equal to 5. Go to y. Your y out of negative 1 is equal to lambda, but lambda is 2, so we shall put here 2, y is equal to negative 2. Go to the z. Say z plus 3 out of 1 is equal to lambda, which is 2. Z plus 3 is equal to 2, and therefore z is equal to negative 1. So for this point here, you are getting 5, yes, negative 2 and negative 1. Come and test also on this second one here and check out also, do you get the same point? Do you get the same point? If yes, you are getting the same point, you go on and also test the same way. So I'll come here and I say, now x minus 4 out of 1 is equal to mu. But what is my mu is 1. So I have x minus 4 is equal to 1, x is equal to 5. Go on the next one. Say y plus 3 out of 1 is equal to 1. Y plus 3 is equal to 1. And therefore y will equal to negative 2. The same thing will happen for z. And you are going to find out that you get 5, negative 2, and negative 1. Since these two coordinates are the same, then it means that these lines do meet. But should you find that the value here, the coordinate and the coordinate here are different, it means that those lines do not meet. Now, after finding out that, then it means that now the next thing you are going to do is to find out the equation of the normal. We say that the equation of the normal for two intersecting lines, just get the direction vectors and cross them. Direction vectors are these ones down here. These ones down here. So that means that our normal here will be I, negative j under k, and we shall have 2, negative 1, 1, and 1, 1, 2. And therefore, you come up with your normal. So can you first come up with your normal and you tell me what you have? For your normal, come up with your normal. Matia is getting negative 3, 3, 3. Matia, check out. Is it negative 3, 3 for the normal? Me, I'm not seeing the negative 3 coming out because, oh, okay. Okay, I've seen the negative 3. I've seen the negative 3 come out. Negative 3, negative 3, 3. Very good. People are getting negative 3i minus 3j plus 3k. According to people, that's what I'm seeing in the chat. So in case that's not what you're getting, please, Hans is getting that. Linda is getting that. Mattia is getting that. Okay. So let's get that. Let's look out for that. That is it, Bettina. Okay, good. Now we say that after getting your norm, then it is very okay for you to come and say the normal r dot n is equal to n dot a. So our normal is -3, -3, and 3. And our r is x, y, and z is equal to our normal, which is -3, -3, 3, and then times a point. A point, feel free to choose either from line L1 or line L2 or use the point of intersection. It is very okay. So allow me for me to use this. But for whatever point you use, you get the same. So this will be -3x minus 3y plus 3z is equal to, then you multiply -3 times 1 is -3 plus 0 plus -9. So this will give us -3x minus 3y plus 3z is equal to, this is -12. Now, never leave your equation when it is not reduced. As long as you can reduce, you reduce. As long as you say common factor, please divide throughout. So here I can divide through by -3 such that I get x plus y minus z is equal to 4 as my equation of the plane. For those who have not divided by negative, then for you will be -x minus y plus z is equal to -4. I don't know whether we are on the same page. Yes, that is okay, Linda. Anyone we are leaving behind? Yes, we are. Okay. Okay, yes, Dr. Peace. I've used for line L1, Bettina, for this one here, which is 1, 0, and -3 for line L1. But for you can use this second one. You can also use the point of intersection. Yes, Dr. Peace.
Teacher, I was asking that is there a possibility of those two lines being perpendicular? And if there is that possibility, so do I need to go through all those steps, finding point of intersection, what?
Okay, if they are perpendicular, then that one is okay. But still, when they meet, for these cases, you may not find that case whereby they are perpendicular to each other. But that one we shall first look out when you can get such a case. Those are some of the special cases we shall look at.
Okay, thank you.
But as long as they meet, because remember, the instance of a normal vector is to find out, even if you find that they are perpendicular, the instance of a normal vector is to find out which vector is normal to both of them. Yes.
Thank you.
Okay. Okay. Now, cuts, I think we said that when you are getting the cross product, remove this and this. So you are going to remain with this. So you will say -1 times 2 minus 1 times 1. So -1 times 2 is -2 minus 1, which is -3. For the second, get this. So you have 2 times 2 minus 1 times 1, which is 4 minus 1. Yeah. Okay. Okay. So we are going to continue. In fact, for this one, in case for you want, also let me say this is your line and this is your line. You know this point already. This is the point of intersection you had obtained. You know one of the points along the line. Let me say you know this point along the line. Then it is also okay. Someone may decide to use this direction here. You can obtain your new direction and this direction, and then you cross. Another person could as well, in case you want to approach it in another way, still the same number. You could say, for me, I have my 3 lines. Why don't I get 3 points on those lines? Someone may say, Here, I know a point. Here, I know the point, and I know another point here. So I have 3 points. So you can as well use that approach. So there are quite a lot of ways. Yeah. Can you take a screenshot? This one, you will do it in your free time. Test whether they are perpendicular. Test whether they are intersecting. And remember, Dr. Peace, we have only 3 cases for the lines. They can either intersect, they can be parallel, or they can be skew. So the angle in between will not matter. Even when you find that you have the angle between is 90 degrees, still they do intersect. Go on and find the norm. Okay, hope members have taken a screenshot. Yeah, if they are perpendicular. Okay, if they are perpendicular, that is an indicator that they do intersect. If the lines are perpendicular. Okay, hope members have finished. Yeah. Okay. 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 Now we are going to look at another case. Okay, we have the last case. Equation of a plane passing through 2 parallel lines. Now, this is very important. Yes, we have 2 planes and we have a plane and we have 2 parallel lines. I think I showed you those lines. Now, what do you do? If this is your plane and you have, let me say this is line L1 and this is line L2. This is line L1 and this is line what? L2. And you want to find out the equation of those planes. What do you need to do? Now, please take note that when you are finding an equation of a plane, it is only possible when you have either parallel lines or you have lines that do intersect. But when it comes to skew lines, those ones don't lie in a single plane. So what are we going to do? If we have 2 lines that are parallel, the first thing we do is that first find out a point on those lines. Take an example. I'll find out which point is here. Let me say this is point A. And I have a point here, point B. These are the 2 points I do have along the lines. And remember, what did we say? We said that when we have 2 points on the plane, then those 2 points on the plane can help us to find out the equation of the normal. But what do we consider? There, we consider our reference point to be 0, 0. Hope you remember that. So when we have 2 points, what are we going to do? We are going to come here. We have 2 lines and so I can first join the line like this. After joining this, I have 2 vectors. Because we said the moment you have 2 vectors, it is very okay. But here for parallel lines, I have A and B. Remember, this line here has a direction, this line here has a direction. So if I want to obtain my norm, it means that my normal can be this vector here, which is D1, cross this second vector, which is A to B. Whereby AB is the known point on the line L1 and is the known point on L2. Members, let me know whether that is okay. Have you understood that concept? How we can get a normal for 2 parallel lines? Not yet, not yet. Okay, I'm going to repeat. Let me repeat, and then people can ask. I've said that if I have a plane This is my plane. And I have a line. This is line L1. I have another one, which is L2. You know very well that when we are writing a line, I'll have okay, let me use OA plus lambda D1. I'll have R2 as OB plus lambda D2. Okay, mu lambda D2. Now this is my first line L1. OA is any point along this, which is A. And then this line has direction D1. Then when it comes to R2, this is my point B on R2. You can place it anywhere, no problem, as long as it is on line L2. But its direction is what? Is D2. Now, if I am interested in finding out the normal to these vectors, what am I going to do? Remember, for the line, you must either have two vectors along the plane. So this is one vector D1 and this is D2. But D1 and D2 are the same vectors. Remember, these are parallel. So D1 is equal to D2. That means that once you cross these ones, you end up with nothing. Hope that one is okay. Being that they are parallel, these two vectors cannot help you to get the norm. So how am I going to find? I'm going to find my second vector by joining A to B, which are the known points along the line, such that I can have this as my second vector and this as my second vector. So this is one vector and this is the second vector. So to get the line that is normal to both, this line here that is normal to both, I'll have to get the direction vector times A cross B. And now that one will give me my norm. Is it okay? Not yet. Members, is that fine? Not yet. Okay, members are saying good to go, good to go. Okay, teacher. Now we can now start. And here, do not confuse it with other concepts where you have 2 points. The procedures are almost the same, but when you have 2 points only, there we use the reference as the origin. So let me pick this hand from Bettina. Yes, Bettina.
Good morning, sir.
Morning.
So can't you have how getting the norm and you equating it to n is equal to d2 times BA?
It is okay. You get the same answer.
Thank you.
Yes, okay. Okay, we are going to start with this. Yeah, so here, the question has stated it that they are parallel lines. But please, always it is also okay for you also to first check out a distance surely parallel. So we are going to first have our first line. This is our first line, which is 2 minus 3t minus t into 1 plus 2t. Always it is a good practice. First check out because the question may say, and actually when you look through, they are not. So I'll have x, y, and z. And when you check here, this is 2, 0, 1 plus our t into negative 3, negative 1, and 2. That is for the first line. Then for the second line, when you look at it, we have x, y, and z. And this line is 3s, 4 plus s, and 5 minus 2s. So what are we going to have? We shall have 3, 4, and 5, then plus s into 3, 1, and negative 2. Now, the next question you ask yourself, are these lines parallel? Look at the direction. This is just for your understanding, but in case the question mentions it, it is also okay to go and check out actually whether they are parallel. So when you look at, this is our direction for line 1, and this is our direction for line 2. If two lines are parallel, it means that their directions are the same. In other words, there is a scalar, which when you multiply, you get exactly the other. So how do you test? Get the x out of the x of this. So this is negative 3 out of 3, negative 1 out of 1, and 2 out of negative 1. Negative 3 out of this is negative 1. This is also -1. Also, this is -1. Since they are the same, it is an indicator they are parallel. Yes, just that is just to remove the doubt that everything now is okay. Now, since we know that these two lines are parallel, it means that if I have my plane, this is the plane. I have this is my first line and this is the second line. Members, this point here for the second line, this is what I can call my B and this is my A. So I have my point A here. For this one, I have my point B there. So what am I going to do? I'm going to first get my AB. So first find out A to B. So A to B, like we have said always, is OB minus OA, whereby O is the reference point. So what am I going to do? I'll get my O to B, Okay. Yes, Manuela?
I think you've made a mistake on point B.
Okay, thank you. You're right. This is 0. Okay, thank you. So continue. Take us through, Manuela.
So shall have 0,
Mm-hmm.
4,
Mm-hmm.
5,
Mm-hmm.
minus 201.
201. What shall we have?
-2.
Mm-hmm.
4 and 4.
4 and 4. Thank you. So this is our A to B. Now your next task is to find out what is the normal. So when it comes to the normal, now here you have to be careful that when you look at how I've used A to B. So that means I've considered this direction here. So for this direction, I'll use this direction such that I get this what? This normal here. Okay, so I'm going to erase this and we get our normal vector. So our normal vector, it means that I'm going to have one of the directions, I cross it with A to B. It is okay. Someone may decide to cross this. Yeah. So what am we going to have? Our direction D. I'm going to consider the first for this first line or the second one for it, whatever thing you want. So it is going to be I minus I, K. So the direction for the first one was -3, -1, and then this was 2. And we have obtained -2, 4, and 4. Okay, someone may compute and you tell us what you come up with. Okay, so from my computation, this is -4 minus 8, which is -12 I. Then when I remove this, for you do it, this is -12 minus -12 minus 4, which is -8. Then the other 8, this is plus 8j. Then this is -12 minus, you remove this, -12 minus 2, which gives you -14. So this is going to be -14 of k. This is your normal vector. So in order for you to get the equation of this plane, what do you do? To get the equation of the plane, just come and say now your r dot n is equal to n dot a. Last time it's okay. So this will be your x, y, z, -12, 8, and -14 is equal to the normal, which is -12, 8, -14, then dot your A. Now, feel free here. You can either use this point or use this point. It is okay. Any point as long as it is on the plane will work. So this time I can decide to use this one. Any point you use 0, 4, and 5, you get the same answer. Yes, please.
Teacher, what if instead of using n equals d1 cross ab, I use n equals d2 cross ba?
You get the
Do
same
I get?
answer.
Okay, thank you, sir.
Yes. So here you do your calculations, do your calculations, do your calculations. So this side, I'm noticing you have negative 12x plus 8y minus 14z is equal to 8 times 4 plus negative 14 times 5, negative 38. So I end up with negative 38. Now, in case there is something that can reduce, please go on and reduce. A case in point here, it can be by 2, or I can say by negative 2. So if I say by negative 2, then that means that here you remain with 6x minus, that is going to be 4y. This is going to be plus 7z is equal to 38 by 2, which gives you a 19. Yeah. And therefore, that is your equation for the plane when you have two lines that are parallel. Yeah. In case you have a question, kindly ask. In case you have a question. Okay. Yes, Tashobia?
What I wanted to ask now, if I decide to use D2, do I still use AB or I use
Yeah.
BA?
You even if you use AB, you get the same answer. As long as those vectors are on the plane, the answer will remain the same.
Okay. Thank you.
Okay. Yes, Gilbert?
Yes, Master, for me, like as we are starting this question, we first proved whether it is parallel. So I'm asking if in the question they have already told you that the lines are parallel like this one, is it a must that you must first prove or you can just continue considering they are parallel?
Okay, one is just to be sure that what you're working on is parallel. I always advise you first test out because I've seen questions that have been said whereby they are not parallel, but you find someone using the parallel approach. So there you fail because the approaches are different.
Yes.
So to be safe, if you have time, you can first test out. Just seeing, you look through and then see whether there is a scale. Even if you don't show the working, as long as you can use your mathematical eye and look through, then it is okay. Okay. Now, members, I also want to let you know that even if you don't use these points that have been given, you can create another point along the line. Now, when you say t is equal to 0, that is a point. Even if you say t is equal to 1, that point still lies along this line. Even if you say t is equal to 3, that point still lies along the what? The line. So that one, please take note of that. Okay. Members, should I show you the second method or we go with this one? You can let me know. Do you want the second method or this is enough? Should I show the second method? Okay, people are saying we want. Okay. So I'm going to remove this. Now, the second method is here. The second method is here. Like we have said that this is our plane and you have your parallel lines. Remember, we have already obtained this point A. This point A was 2, 0, and 1. We have this point B, which is 0, 4, and 5. Now, what do you do? What I can do is that I have 2 points on the line. I can check out for another point, let me say C, in this plane. That C can be on this line or it can be on this line. Take an example. When I come here, when I set T is equal to 0, I'll find my point A. Because T is equal to 0, when you substitute here, it will be 2 minus 3 times 0, negative 0, and 1 plus 2 times 0. So that is the point 201. When I say to get another point along this line, I will just say T is equal to 1. So when T is equal to 1, I will say 2 minus 3, which is negative 1, comma, here I'll have negative 1, comma, 1 plus 2, I'll end up with 3. So I can get another point along the line, which I can call C, and this is negative 1, negative 1, 3. If I don't want to use this, I can use a point along this line by saying when S is equal to 1. So what happens that you have now 1, 2, 3. So you remember when we looked at that concept whereby we had A, we had the B, and we had the C. So here, what is going to be, so let me draw it very well. Let me draw it very well. So what do we have? We have A here, you have point C, and you have point B. So if you have 3 points along the line, you can go on and find a normal. How do we get the normal? You are going to get the normal by now getting your vector A to C cross your vector A to B. Only. And then things will be okay. So now here you are going to allow me that to get your SC, you know that SC is equal to OC minus O to A. Now our OC, I've used negative 1, negative 1, 3 as my OC. So it's going to be negative 1, negative 1, 3 minus my OA, which is 201. So here my answer is going to be, that is negative 3, negative 1, and 3. Our AB, we had obtained our AB already as negative 2, 4, and 4. So when you get the cross product of those two, I'll have negative 3, negative 1, 3, negative 2, 4, and 4. This is our I, negative J, and this is K. So I'm saying when I get I, this is negative 4 minus 12, negative 4 minus, this is negative 3. Okay, sorry. Here, this is 2. I don't know why I wrote 3. This one down is not 3. When you look here, 3 minus 1 is a 2. So here you have a 2. So when you remove this one, it will be negative 4 minus 8, which gives you negative 12i. When you remove this is negative 12 minus 4, right? Which we shall remain with negative of 8j. When you remove the last one, this is negative 12 plus minus 2, which is negative 12 minus 2, which is negative 14. I don't know. Let me be very sure. Just a minute. This is negative 4. Okay. Negative 4 minus 8. Yeah. Hope it is okay. Let me first repeat just to be very sure. So when you remove this is negative 4 minus 4 times 2, which is 8, which is negative 12 of I. When I go to the second one here, it will be negative 12 minus 4, which gives us negative 12 plus 4, which gives us negative 8. But because there is the other negative, it becomes a plus 8 of j. Then the next one here will give us negative 12 minus. So that one I think it is okay to be negative 14k. Yes. Okay. Yes, Linda?
Excuse me, sir. If that get that normal, I've understood it, where to get that. Where to get that point C, I'm ready. You just assume that T equals 0, T to 1, there I'm lost.
Yeah, like I've
Get
told
that
you,
point C.
Yes, to get C, you can say T is equal to 1, T is equal to 2, any value for the parameter you want.
Okay.
Eh,
Meaning I can also use S.
even you can use
I can
S.
also assume. Okay.
Yes, you can
Thank
use
you, sir.
S. Okay. So this is your normal. So after getting this normal, then you just go back and then say that now my normal vector times my R should give me your n dot A. So you're going to notice that if I remember very well, this is what we had. So you get the same answer. So then after you continue normally and then get the answer. Is that method okay? Okay. Let me, yes, Santos?
Good morning, sir.
Yes, morning.
My concern is if I'm to say like t equals to 0 or t equals to 1, how do I estimate to see that these values I've used are on the plane? I'm also allowed to say if t equals to 10.
Whatever value of t you let will be along the plane. It's like the way
Okay,
you have these equations of a line. Y is equal to 2x plus 1. For whatever value of x you say, when x is 1, when x is 2, any point, any value of x you mention is along this line.
okay, sir. Thank you.
All right. Yes, please.
Teacher, I wanted to ask you. First of make a small like there up in the formula R dot N is equal to A dot N. For the position of S, can I use even that C which I've created for myself?
Yes, please. Even if we use it, we get the same answer. As long as that point is in the plane. So you are going to say that you have negative 12, 8, and negative 14. If we use that C, even if you don't even use any point, negative 1, negative 1, 3, this is going to be 12 minus 8. Then that is negative 14 times 3, which is negative 42. So 12 minus 8 minus 42, you end up with negative 38. So it's the same as, then you say negative 12x plus 8y minus 14z is equal to negative 38. You get the same answer. Even if someone here had said that let my t equals to maybe 20, it is okay. Even if you had said let my s, even here for s, even if you had let your s be maybe 50, for you, for whatever value you let, that value is going to be along the plane. So you can use it, you get the same answer.
But it's kind of unbelievable.
For you, just as long as the point is on the plane, yeah, you get the same answer. Yes, Jimmy. Mm.
You told us that we have to reduce on the final answer.
We have to
Reduce on the final answer if possible.
very.
Then, Master, we've been getting that like negative x plus y plus is equal to some and any value. Now, do we divide by that negative to make the x positive? Isn't it the better?
It is okay. You can make it better by dividing, or you can, as long as you have reduced to its simplest form. As long as you have reduced to the simplest form. Okay. I think members. Now, this third method, members, it is the same method. You remember when we looked at finding the equation of a plane when we are given 3 points. This is the method I'm talking about. So the equation of two parallel lines is related to what do you do when you have 3 points on a plane. That was the second thing we looked at. So you can first revisit how we did it. It is the same way. It is the same way. Even here, you can use the other vector equation. You can also go on and use this approach of OA plus T of AB plus T A of C. or lambda. You can use that one. You get the same answer. Yes. So getting the third point gives you 3 points along the plane that can help you to get it there. Yes, Dr. Peace.
Teacher, I'm just asking whether this lesson is going to be there on YouTube because I missed out the first part of the lesson. I came late.
Yes, it's going to be there. It's going to be there.
Okay,
Okay.
thank you.
All right. Members, can you take a screenshot of this? Take a screenshot of this as part of our exercise. Yes, Lydia? Lydia? Okay. Okay, let
Good
me hope.
morning, sir.
Morning.
Excuse me.
Yes, please.
Teacher, on the second approach, do you use any point
Yes, any point you
to
use.
find the equation?
Perfect. Any point you use, you get the answer.
But I've been getting wrong things.
Which point did you use?
I used the AB.
No, AB is not a point. AB is a line. It's a vector. AB is a vector. So if you are using a point, you must either use point A or point B or point C. This is a vector. It's not a point. It's not a point.
Okay, teacher, thank you.
Okay. Okay. Yes, Dr. Jimmy?
Master, I'm sorry to ask this, but I would like to know the remaining part of these vectors, Master.
Oh, okay. Okay. Just give me a minute to stop this recording and